All right, everybody. So today is Quadratic Transformations Day 2. Today is Monday, March 1st. So first things first, let's go ahead and review what our parent function looks like. First off, you want to go ahead and pull up Desmos and graph it in that calculator, and then make a sketch on your paper for me. I was graphing it in Desmos. Here is what it would look like. So here's what it looked like on my graph with just a couple points. And what my table would look like. All right, so we're going to hit on a few more transformations today. So first things first, I have 2x squared. 2x squared. Let's go ahead and let's pull up Desmos and let's see what this looks like. So here's my graph. Y equals x squared should already be in there. But this time now I have y equals 2 parentheses x parentheses squared. So let's take a look and see what this looks like. So the red one here is my parent function, while the blue one is my new equation. So what happened then? Well, I'm still at the same vertex, but this here got smaller. So the question is, how did it get smaller? Well, what we call this is a vertical stretch. What happened was they took the parabola, the parent function, and they pulled it from the top and the bottom, and they stretched it just like you would a rubber band if you grabbed it on the top and bottom. They pulled it and stretched it. So we're going to call this a vertical stretch. Now again, if I go back to my graph here, and let's say I wanted to take a look at the table here, some of the coordinates on the table, 0, 0, -1, 2, -2, 8. Those are like some of the coordinates, 0, 2, 8. And those are the coordinates I would plot. So my vertex did not change at all with this, but my coordinate of -1, +1 now became -1, +2. And then same thing here, +1, +2, and -2, +8. It shrunk it a little bit, it got smaller. It vertically stretched. All right, next we have 1/2 x squared. What do you think is probably going to happen here since it's a fraction? The other one was a whole number, this is a fraction. Hopefully you're already thinking, well, maybe it's not going to stretch. Maybe it's going to get wider. Maybe it's going to get bigger. Let's see if that's the case. So I have y equals 1/2 parentheses x parentheses squared. And notice the green did get wider from the red and from the blue. The blue was the stretch. The red is the original. Green is the what we call vertical compression. So with the compression, what's happening is we're taking the rubber band, the parent function, and we're pushing it down and making it wider. So it's still at the origin, but now it's getting wider. than what it was before. So we still have 0, 0, but now we have negative 1.5 and 1, comma 0.5. And then instead of 2, 4, we have 2, 2. And that's about what it looks like. All right, so what happens then whenever they're inside the parentheses? Well, whenever we're inside the parentheses, what changes is just the opposite. We're now not dealing with the vertical ones that we just had. We now are going to have something that is a horizontal. So the question is it a stretch or a compression? Well, let's see. This time we have y equals parentheses 2x squared. And notice it got smaller again. It got smaller from my original parent function, which is here. There's my parent function. Here's my new one. So before we called that a vertical stretch. But if I'm going horizontal this time, a horizontal would be a compression. So this is going to be a horizontal compression. The reason we know it's horizontal is because we're inside the parentheses. Anything inside the parentheses is always going to be horizontal. Anything outside the parentheses is always going to be vertical. So this one is going to be a horizontal stretch. The best thing I can tell you guys to be able to figure out which is which is look whether you're inside or outside and then graph it and compare it to your parent function, okay? That is my best suggestion to decide whether it's horizontal or vertical, is look inside the parentheses. Are you inside or outside? And then decide if it's stretch or compression by actually looking at the graph. Now, if you want to know it based on the equations, for vertical stretch, if your coefficient is bigger than 1, it's a stretch. If your coefficient is less than 1, if it's a fraction like that, and it's less than 1, that's a compression. If it's a compression horizontally, it's inside the parentheses and bigger than 1. If it's inside the parentheses less than 1, then it's a horizontal stretch. All right, everybody, that is all your transformations. Go ahead and go work on your homework.